So I guess Jeff Fry was here 2 weeks ago, and he introduced zEnterprise and sort of the big picture of what we were trying to accomplish with that, what the objectives of zEnterprise were, and sort of an overview of the hybrid nature of how we're trying to combine traditional Z with Power and x86. So what I want to do today is sort of take it down to a little more detail and go through the major components of zEnterprise, and also what we call the Unified Resource Manager, which is a sort of a management framework we put on top of the hardware and virtualization environment to manage the environment. So let's see, how does this work? Okay. So basically what I'll go over, I'll talk about the zEnterprise system, what its major components are, what its structure is, and then discuss the Unified Resource Manager, which is this management framework, talk about the major functions and capabilities it has, the management it can do of the environment, and then I'll briefly discuss some interfaces we've introduced for other products, other tools to interact with it and provide control, which might be interesting, I think, for this environment. So Jeff basically showed this picture, which is sort of the big picture view of the components of what we call the zEnterprise system. On the right is the zEnterprise, which is the next generation of the traditional Z mainframe, sort of building on its strengths in commercial areas to host large-scale databases for transaction processing. Also growing in use for hosting Linux, sort of being able to consolidate large Linux sets of Linux systems. Designed for being able to do a lot of large-scale scale-up. This picture shows the larger model, which we introduced last year, which is called the Z196. We just introduced a smaller model of this system called the Z114, what we're looking at here. But it's got the same characteristics. It's just a smaller model.
Peter,
is
these version 1.12 of ZOS, is that the minimum release level that people would need to run?
No.
To exploit Unified Resource Management?
No, actually, we have rolled back the support back to ZOS 1.10. So, yep.
Thank you.
Yep. Then on the right side here is what we call the zEnterprise Blade Extension, or ZBX. This is where we can then host, associated with System Z, IBM Power Blades and x86 blades to be able to run AIX applications integrated with Z, Linux applications running on x86, and then we'll be introducing the ability to run Windows at the end of the year, Windows applications on those x86 blades. Also, we use the ZBX for some tailored solutions that are single-purpose hardware software solutions that are aimed at either optimizing workloads running in the environment. One example of this is what we call the data power solution, which is a blade which can optimize certain web services XML sort of processing. So that's a sort of a fixed-for-purpose single solution that's in a plain form factor that can also be plugged into here. And then tying all this together is what we call the Unified Resource Manager, which is basically a management framework that provides a consistent way of managing this whole environment. And it's kind of what we think is one of the major value propositions of the overall solution, because it provides consistency for managing across all these different environments, while in a more traditional distributed environment, each of these systems would have their own approach to management, different tools, different ways of doing things. The goal here is to provide consistency to simplify the management of the environment. Oh, yeah.
The URM is primarily software, right? It's firmware.
It's actually, it's firmware that ships with the box. So the advantage of that is it doesn't need to be installed. It just comes with the box.
I just like the picture of firmware.
Oh, yeah, you like the,
I've never seen it.
it's kind of a hard thing to visualize, so I guess that's not a bad way to do it.
Magic.
Yeah. So I think Jeff also showed a picture that looks something like this. This is kind of the big picture, logical view of what one of these zEnterprise systems look like. On the left here is the traditional Z environment, where you can run the existing ZOS System Z operating systems, which include ZOS, Linux, and there are a couple other operating systems, TPF, VSC, that are run on System Z. With Z, there's sort of potentially two levels of the way we virtualize the environment. There's the built-in hypervisor we call Prism, where, at least, for example, in big commercial systems, customers would tend to run their production ZOS, which might be the place where major databases and transaction processing systems are hosted. ZVM is a separately installed environment which can provide a second level of virtualization, which is often used to run Linux on System Z, which can provide the ability to really scale out the number of Linux systems running on Z.
Could I ask a question about that, since I think, Linux is probably, going to be one of the operating systems that's going to be important to the researchers
Sure.
here. In terms of especially, computational type, activities, what's the advantage of running, Linux on System Z right on top of the System Z TRSM system as compared to ZVM?
I think they probably,
Disadvantages.
the advantages of running right on Prism are, one advantage is you get higher performance access to the I/O capabilities of the environment. So if it's a very I/O intensive workload, there may be advantages to run that in right on top of Prism. Running on top of Linux, on top of ZVM, you have more. It's a more virtualized environment, so you have the ability to sort of more flexibility in creating these virtual server, the Linux systems on ZVM. You can create a larger number of them because memory is virtualized to the guest on ZVM. It's not virtualized on the base Prism environment.
Peter, can I add a few points?
Oh, sure.
What we've seen from customers is when you run on ZVM, you have the ability to dynamically change performance characteristics. So you can, for example, you can overcommit memory or CPU. So you might have 2 IFLs but 25 guests running because they're not all running at the same time. And you can change the weights in ZVM to give different research projects different priorities depending on the time of day. Or you can, because it's more virtual, you can overcommit that memory so you can have more memory allocated, and if ZVM has to page out, it can do paging, so that you can get a lot of things running at the same time, but you can balance their performance. And I can also tell you that we very rarely see customers running directly on the hardware. Again, because you define an LPAR, it's going to have a fixed amount of memory, it's going to have a fixed amount of CPU, and Prism cannot do as much dynamic workload sharing as ZVM can. So I've been told the overhead is about 2 to 3%, so you might get 2 to 3% performance improvement, but you're losing the ability to overcommit memory, to dynamically change weights and priorities, and then you lose access to a few other resources like virtual switches to create subnets amongst some of the guests if they have to communicate with each other, but isolate from somebody else. So there are advantages to being inside ZVM.
Yeah, it basically is a better way to manage, all these guests, okay?
Yeah, I think thanks, that's a good description.
The newest release of ZVM also supports a couple of very important features that would be useful in an educational and research environment. You can dynamically move guests while they are running from one place to the other. And you also have the ability to, actually it wasn't just this recent release, it was released before that, where you can actually dynamically add more memory to the guest, real memory. And it also supports some different kinds of devices that are not supported normally by the traditional ZOS, ZTPF, ZVSE environment for different kinds of I/O attachability, sharing of SANs, virtual disks, and things like that. The overhead is very minimal. Having been involved before VM was made available to run Linux, it was quite cumbersome to do it under just the Prism environment, and VM really made everybody's life much easier, and virtualization's really, I would almost say that the virtualization piece is actually more important than it being able to run Linux when you look at it.
Let me just ask this question. As a user, when I log into this, I'll just see a Linux prompt.
Right, you would, yeah, this,
Or
Right.
Linux desktop, or however it gets set up, I don't know if it can do windowing environments or not.
That's correct.
Right,
But
correct.
the virtualization is not, that wouldn't be on my
It's transparent.
shoulder.
However, there is something that recently occurred this last year to 18 months or so ago, if I remember correctly. At the recent Z Technical University Conference that took place earlier last month, IBM endorsed a product which we happen to represent from Israel now, that we can have the school actually try here. I recommend it very highly. That helps mask the ZVM technical skill normally needed. It's a product called CSL Wave. It's fabulous. Everybody we were showing it to was immediately adopting this thing.
Scott wants that mask.
So,
I was curious.
what's good about it?
Involved in setting my memory settings and stuff, so if I would basically just say, I want a server.
Yes, it's exactly what it is. It's all point and click graphical interface, and it takes care of all the underlying VM executives, Rex execs, and things that need to be built into this.
If you let me set my own, I'm going to take all of them.
That's an administrative tool, so I mean, if you assign a guest to a person, you SSH into it, you have a machine.
Okay.
Right.
From an administration perspective, this tool makes it easier for the administrators.
Very, very good for Linux people that don't want to know or need to know, can just start up their own server. There's rules and things that can be set so you don't overstep your boundaries or take over the whole machine or something like that. So the administrator can manage that, things like that. So it's very powerful.
To continue, we could always set something up with Angel.
Yeah, we can do something later.
Yeah.
Okay.
Sorry about that.
So, any other questions around that? So that's the traditional Z side, and then on the right here is the ZBX environment where we can run Power blades and x86 blades. These are also virtualized, so as part of the environment, we ship the hypervisor that supports virtualization on both these blades types. So it's AIX on Power. Right now, it's Linux on x86 and soon Windows on x86. And then also, in addition to these general purpose environments, where any application that's supported in those operating systems could run, there's these special purpose optimizers, which I talked about, for example, the data power. We would expect to do more of those over time.
Did you say very soon Linux on Power? Did you just say that?
No, Windows on x86.
Oh, Windows.
Yeah, right now, we don't have Linux on Power. From the point of view of the operationally managing the environment, there's the G Hardware Management Console, and this is where the operator and operational staff would do the work to set up the virtualization environment. Traditionally, that's been used for the Z part of this. We've extended those capabilities out to manage the ZBX side of this. So that's part of providing consistent management across this whole environment. Now, the same approaches for managing the Z side of this can be used to manage the work running on the ZBX. So setting up the environment, setting up the servers, getting the OSs installed is done in a consistent way across the environment. I'll talk a little bit more. There's also networking capabilities. There's a built-in network, so the applications running across the environment can communicate. I'll talk a little bit more about that. And there's also a separate network for providing the management of the environment, so that all the management infrastructure can communicate with the different pieces. There's built into the Z system is what we call the support element, which is actually a laptop in the system Z, which is sort of the management portal to manage the hardware and virtualization environment. We've extended that capability to manage from what it does for Z to also manage the hardware on the ZBX. So again, that allows us to provide consistent management across this environment. Any other questions about this sort of basic structure of the environment? Okay. Do it that way. Yeah, that works too. Just briefly looking at physically what this looks like. Whoops. Now okay, it was just being a little slow. Physically, we've got the system Z that looks like it traditionally would. The ZBX is one or more racks where these blades run. There's basically a set of blade center chassis in these racks, and the different types of blades can be installed there. We support a specific set of blades in this environment, and only those blades, so we can...
So we can't take some of the blades that we have in our existing equipment and put it in the ZBX?
No, unless they match the configuration that we support.
It's possible, okay, but it's very specific to configurations for the blades.
Right.
Okay, and, yeah, oh, okay.
Okay, yeah. The idea being here is we want a fully tested environment, so we've tested with all the different configurations that are supported.
Dr. Norton, even if you had the correct blades on your floor and another blades on a rack or something, you would not be allowed to take it out of there and put it into here. It's a policy of the zEnterprise architecture.
Okay, so that's just sort of another sort of concept we're introducing here is what we call the zEnterprise ensemble, which is essentially a collection of zEnterprise nodes. That picture we looked at 2 slides ago is what we call a zEnterprise node. It's a Z system with optionally a ZBX associated with it. To a single HMC can manage from a unified resource management perspective, can manage a set of these nodes. So it provides, that's sort of the management domain of Unified Resource Manager. It's up to, it's 1 to 8 nodes. And by having, the HMC then gives you a single point of control for managing that whole environment. A given node can have up to 4 racks for the ZBX with up to 2 blade centers in each rack, and that works out to be like 112 blades per node.
That's what we want, right?
Can we get, can you put 2 of those?
We'll take care of that for you.
Then, so a given node is only a member of a single ensemble, because that's how it's managed. It wouldn't make sense for it to be a member of multiple ensembles. And then for redundancy, for the hardware management console, there's basically a second one that acts as a backup. So if the primary one fails, there's a takeover to provide high availability, since it's the management point for the environment. One of the functions we think is a major value proposition of this whole environment is the networking that's provided. You can sort of think of there's three networks, three types of networks involved. There's the existing network in the environment, so the external network that connects to the rest of the environment outside of the zEnterprise ensemble, which works the way it does today and connects as it can today into the Z or into the ZBX, so the applications running in the ZBX can communicate externally. Then within the ensemble, we have what we call the intra-ensemble data network. I guess it's not a very original name. It's basically a 10 gigabyte Ethernet that provides the ability for applications across the ensemble to communicate with each other. And then within each node, there's a management network, which is how internally the unified resource management control things. That's pretty transparent to any users, or even the operations staff. The intra-node, intra-ensemble data network, we provide all the management tools for it, so we think this is one of the simplification points for zEnterprise, because it's a built-in network. All the switching needed for that network comes with the system. All the needed management functions for setting up the connections is built in. So that simplifies setting up the communications between the applications running in the environment.
Is that work that you did with Juniper?
Let's see, the switch, trying to remember now.
Doesn't matter. I was just curious in terms of
Yeah.
how Juniper was involved in actually the internal network.
If I remember correctly, some of the switching, we work with Jupyter into the switching in the ZBX. A little bit more about this networking. I said essentially what we do provide across the set of nodes in the ensemble is provide this intra-ensemble data networks. Network is a single physical network across the environment. So physically, any virtual server, any application can communicate to any others. So there's physical connectivity across the environment. But we provide virtualization for that network that allows isolation, so you can control which virtual servers can communicate to which other virtual servers through configuration without having to change anything physically. Another advantage of this network is that because it goes through just components that are part of zEnterprise, we think it's physically secure. It doesn't go through any external routers or other networking equipment. So we think at least, and this may not be that important for this environment, but in a commercial environment, we think that could provide advantages of lessening the need for encryption for that network, which can provide efficiencies.
Well, for Scott's application, it'll be good to know that it's secure.
Oh, that's true. Maybe right.
Navy knows.
Yeah, you can let the Navy know that it's all protected. And we also, just for high availability, all the componentry behind that network are redundant, so if there's failures, there's automatic takeovers and things like that. Just a little bit more about the Power Blades and x86 blades we support. As I said, basically we supply the hypervisor that runs there, and provide this overall management framework. So one of the big advantages, as I've said, is by providing this unified resource manager as the overall management framework, we're providing consistency across x86, Power, and Z for managing how you set up virtual environments, how you connect storage, how you do this networking in a consistent way to simplify managing the environment. Since we provide the built-in virtualization that provides the advantages of virtualization that we talked about a little bit, it allows for sharing of the hardware resources across multiple workloads. But all this is transparent to the applications running there. So any applications that are certified to run on AIX, on Power, or the Linux distributions we support on the x86 blades will just run unchanged. That'll be true for Windows when that's supported. So the blade configurations that we support for Power, they're single-wide blades, they're 8-core, 3 gigahertz, and they come in those 3 memory configurations, so it's up to 128 gigabytes. And they connect in, they have the 10 gigabit Ethernet to tie into the inter-ensemble data network. The x86 blades are 8-core processors with 2 sockets, so it's a total of 16 cores, and with configurations up to 128 gigabytes. And they also connect into the 10 gigabit Ethernet. So that's sort of the capabilities of an individual blade. Any questions about that?
We have here, question.
Yeah, sure.
Well, what are these blades? Is that where data is stored?
Well, the blades are essentially a self-contained system. So it's processor memory connections, so they can be connected to networks and I/O. So it's where work runs, and then you could connect them to, for example, to a SAN where the data would be that they're processing. So you can think of it almost
Brother,
like
you can kind of look at it like a shrunken computer.
yeah, or like the
slice.
motherboard of a computer. If you opened up your computer, right?
Slides in a slot, bro.
One thing I'd like to add, they also have SSD drives associated with blades, so it is complete.
Yeah, though the SSD, that's only used for management of the blade.
Correct.
Oh,
So it's not, those aren't accessible for application data.
oh, okay.
So
So-
all the application data has to be external.
Is there a disconnect for booting the operating system, or does it boot off of a SAN?
It boots off of a SAN.
Okay.
Okay.
It's just normal.
Yeah.
Did that clarify your question?
Thank you. And just a little about the hypervisor we provide on the System X blades. It's based on KVM, which is a Linux hypervisor solution. We support these operating system levels on x86, and we provide the drivers that are necessary to run there. So that's part of what's delivered with the solution. Okay, so that was kind of a look at what the hardware is of zEnterprise. So next I wanted.
It said Red Hat on there, so is Red Hat the only flavor of Linux that?
No, it's Red Hat and SLES are the distributions we support. So next, just wanted to go through the sort of the major functions of the Unified Resource Manager that provide the ability for managing this, the hardware we just kind of went through.
Peter, excuse me.
Sure.
Dr. Norton, do you envision both distributions of Linux being utilized?
possible?
I
Or you
don't
don't know
know,
yet?
everything depends upon what people are doing. So I just wanted to see, what the possibilities were.
Okay. Thank you.
What version of Linux are you have?
It really doesn't matter to us. I think on the workstation there's Ubuntu Linux now. So Debian would be nice, but I don't think it actually matters.
Okay, but you don't have any dependencies on the Linux distributions?
No.
So it's kind of starting with the basic management of the hardware. As part of the Unified Resource Manager, there's essentially an integrated ability to manage across these different hardware environments. So the expected operational controls, how you power things on, power things off, how you update the firmware across the environment, how the hardware detects if there's any problems. We sort of extended the approach on System Z out to the ZBX, so there's automatic detection of problems. The system can basically call back to IBM if it detects a problem, and in some cases dispatch a service person with the failing piece of hardware if it's automatically detected. All the configuration of both the environment, of both the Z and the ZBX, back up and restore those configurations, all done through the interface of the Unified Resource Manager on the hardware management console. Another capability then is managing the intra-ensemble data network, which is which is again how applications across the ensemble communicate. The main function here is to set up what we call virtual networks, which is basically by defining a virtual network and then connecting virtual servers to that network, you can basically control what those who they can communicate with. So to communicate over this intra-ensemble data network, two virtual servers have to be on the same virtual network. So even though it's a consistent it's a single physical network, we control access through these virtual networks. So just in the little picture here, we've got two virtual networks with a set of ZOS partitions, Prism partitions on a virtual network that allows them to talk to an optimizer in the ZBX, and a second virtual network where a set of Linux guests on ZVM can communicate with AIX guests on a Power Blade. But for example, these ZOS LPARs wouldn't be able to talk to these AIX guests given this configuration because they're not part of the same virtual network. Then there's also support for connecting storage up to both the virtual servers running the ZBX, and also this support applies to ZVM. Basically allows what we call virtual disks to be defined, and then associate virtual servers to the virtual disks, which then allows them to access disk out in the sand. So for the ZBX blades, we support FCP SANs, and for ZVM, we support FCP SANs plus the traditional Z storage. There's also capability for each hypervisor, which would be a blade or a ZVM, control what storage resources they're allowed to talk to. So there's access control built in. Sort of the next function here is sort of just the basic management of these hypervisors and virtual servers. As I said, the hypervisors are supplied with the system, so they're automatically deployed to the blades for the x86 and Power Blades when the blades are installed in the system. There's controls to basically start those blades and stop them. the update and service of those hypervisors is done through the standard firmware processes for System Z, so that's consistent. And then we provide the ability to monitor their resource usage, so you can see physically how busy each blade is in terms of CPU and its memory usage. Then, building on top of the hypervisor, there's the capability to manage virtual servers running there, so you can create the virtual servers, delete them, define the resource requirements they need, how much CPU and memory, and then attach them to the networks I talked about, to disks in the SAN. There's ability to attach virtual DVD images for perhaps installing software. There's automation capabilities to be able to start and stop them on a schedule. And then there's a set of monitoring, which I'll talk about a little bit later, for monitoring their resource usage. Okay, so the next piece of function is sort of stepping up a level. Over time, we're introducing a set of sort of higher level policies for managing resources in the environment. And the first of these is around performance. So we've introduced a performance policy that allows for performance objectives to be defined for the virtual servers that are running across an ensemble. And then we use that policy for sort of providing context for monitoring how those virtual servers are using resources, and also to manage how resources are assigned to them. We've actually borrowed some ideas here that have been introduced originally in ZOS, and so this is one example of sort of spreading the approach for what we've done on the mainframe to these other environments, a common management approach. So based on this policy, we can monitor whether the virtual servers are achieving the performance objectives that have been applied to them. And then we can have capability to, in some instances, to adjust the resources that they're using to help them achieve those goals. And I'll talk about that a little more in a couple of charts. One of the building blocks of this management is what we call the workload resource group. And the idea here is to be able to group the set of virtual servers that are supporting a given sort of overall function together, and then use that grouping as a way to provide context for how you manage them. So if there's a set of virtual servers that are supporting a given project, for example, here, and maybe there's a web server involved and other virtual servers doing other pieces of work for the project, they could be grouped together. Then from a single view, you can see the resources that are being used to support them. So that grouping provides the context for how they're monitored. The performance policy I talked about is then associated with the workload resource group, so the policy is assigned to that functional grouping of virtual servers. This grouping is either defined when the virtual servers are initially set up through on the HMC, or if there are other tools that are involved for defining the environment, they could be the one that define these workload resource groups.
Peter? Okay.
Oh, yeah.
Does each function have to be, defined before you assign it to a workload? So let's say CICS is interacting with AIX, that CICS application may have a certain performance criteria. Does that have to be done before you lump it together into a group?
Well, you can.
Do you understand the question?
I think so.
Yeah.
So you can actually, you can do it in a sense either way. It probably makes sense that if you can define these groups up front, because to represent the overall function, and then assign virtual servers to them.
Okay.
You can also dynamically change these associations.
Okay.
I guess when you talk about CICS, though, for example, this is really about monitoring and management at the overall virtual server or LPAR layer. If you look inside a ZOS, for example, for CICS, the capabilities that exist in ZOS today for managing inside ZOS are really unchanged. So that all works as it does today. Oh, yeah, question.
You mentioned the word SANs a number of times. What are these SANs?
Oh, that's a storage. Yeah. So that's basically for disk storage. Basically, it's a way of having a set of disks available for attachment to servers.
Think of it as a LAN with
Yeah.
just storage devices.
Yeah. So it provides remote connection out
Right.
to storage devices for disks, so the applications
Pool
or
of disk,
data.
rather, pool of disk. It's basically a pool of disk.
Yep. Okay, so that's sort of a basic building block for the higher level management capabilities we're providing. As I said, we have this performance policy, which basically, for each workload resource group, there's a policy where is made up of what we call a set of service classes, and then the virtual servers that are part of the workload get mapped to service classes and assign these performance objectives, which then we use for doing the monitoring and management of those virtual servers. And all this is done on the hardware management console. So there's a wizard for creating these policies, for saving them, stuff like that. And then based on that policy, we provide monitoring of how well those virtual servers are doing and what resources they're using. Again, organized by these workload resource groups, so you can see for a given sort of overall function how they're using the resources of the environment, whether they're achieving their goals or not. And from sort of the higher level view, you can drill down to sort of the individual virtual server to see how they're doing, what resources they're using, whether they look like they're performing well, so we can see how much memory they're using, how much CPU, how much network, how much of that. So you can see from that intra-ensemble data network how much they're contributing to the overall work on the network. We provide a set of graphical views and things like that.
Is that a part of RMS, or does that come with the system, or is that a tool?
This basic monitor is done through the HMC, so we've extended the HMC. And then there's also all this data is available through a set of APIs.
Right.
So other monitoring tools, like some of the Tivoli tools, like ITM, will be getting the same data and being able to display it.
How are the resources managed within a class then? Is that also the HMC, or is that, in other words, you have a workload and you put them in a class and you have resources allocated to them, but within those applications, for lack of a better word, where is that management coming from?
So what we can do is, if we can manage the virtual servers.
Right.
So say on an x86 on a Power Blade, say there's a set of virtual servers defined. So we can, based on the objectives that the service class assigned to those virtual servers, we look at whether they're contributing, whether overall that the goals being made or not, and then look at the individual virtual servers and can determine if resources can be moved around to help to achieve those goals. So the granularity, what we can do with is at the level of virtual server.
Oh, okay.
So what this doesn't do is get inside a
Right.
virtual server and manage applications. So within a given Linux,
Right.
and if there are two processes or applications running there, we're not controlling that. That's whatever Linux does,
Oh,
it
okay.
does. We can only control
Right.
the resources it gets overall.
Now, as you're asking about applications, you'll notice that because we don't reach into the operating system, depending on how, it changes how you might want to lay out your environment. So you might not want, right now you might have one Linux guest that is the web server for 5 different applications, because now you've got one web server. But from a URM perspective, we can't recognize what the web server is doing.
Yes.
So now you might
That's my
want to,
question.
you might want to tie a virtual guest specifically to an end-to-end workload, as opposed to having a whole bunch of shared resources. because that way the Unified Resource Manager can now say, oh, I've got 5 web servers, but this one is more important than this one. So it can balance the CPU priority and the memory because it can see it, but only at the guest level.
Right.
It can't see inside
Yeah,
to the application
Yeah.
level.
Okay.
that's a good point. So,
If you want to look at it at an actual application level, there is software that you can add into the system. One of the tools that allows you to do this is this thing called typically Workload Scheduler. And it'll look at each of the individual applications that are running inside. And one of the recent announcements that just occurred when the Z114 was just announced here in July is there's a set of APIs that the Unified Resource Manager opened up to interface to these tools, like Tivoli's tools and Computer Associates tools,
Oh, okay.
EMC's
I
tools.
mean, I can understand you not wanting to get to that level of granularity, but something, you
Does
can't
need
just
to.
say, just
Yeah.
wave your hands and
Yeah.
say, well,
No.
best
It's
of
like
luck to you.
watch this space.
Yeah.
Stuff is happening here.
Yeah, right.
But, you don't want to overstep the bounds of a Unified Resource Manager, which is managing
Okay.
hardware.
Right.
When you take these APIs and you combine it with something larger,
Sure.
now you can start to see these things getting even more integrated in the future. But for right now, Unified Resource Manager manages virtual machines.
Okay.
And it groups virtual machines together so that if you find out that you've got one workload that's got an x86 web server and a database on ZOS and an application level on a P partition, if one of those is not getting enough resources and that whole workload is more important than other things,
Okay.
you can start to, you're managing now at a group level,
Yeah.
not at a single level, which gives you better overall performance for everything and meeting your goals.
Because otherwise, you used to have to do that all manually.
Right, right.
And no wonder you take guesses at it.
Right.
This really helps your
or
results.
over-allocate so you
Over-allocate.
you don't get in trouble. So one of the
Right.
advantage of having this level of dynamic management is that, and especially by having the system understand relative importance of things, you don't have to over-allocate as much because the system can make sure resources get to the work that really has to get done.
And the choice was made this way so that you don't have to modify the operating system to recognize what
Yeah.
hardware it's on.
Okay.
If we went into the application level, you have to now have a hook.
Yeah.
And you'd have to say, well, this operating system has to be changed,
Okay.
or a plugin has to be installed, or something.
Right.
And the goal was to avoid that.
Yeah, and that was an important goal, because we really wanted stuff to be able to drop into this environment and not ask people to go change. Or And actually, speaking of the management, this chart just kind of gets to that in a little more detail. I guess this is a little animated here. So I forgot this chart was not animated. So we have the capabilities we were just talking about to manage how CPU is assigned across a set of virtual servers on a given blade or on ZVM. We can do this today for the Power Blades and ZVM. And basically, so we have these goals in the policy assigned to the workload. We monitor all those service classes to see if one isn't achieving its goals. If we find one that's not achieving its goals, we figure out what virtual servers are part of it and whether they're having performance problems. If we find such a virtual server, like in this case, we build a model of how CPU is used by the virtual server and how that affects its performance. So by having that model, when the virtual server is missing its goal, we can figure out whether if we provided more CPU to the virtual server, whether it would do better or not. If that's the case for such a virtual server missing its goal, then what we do is we look at the other virtual servers on the same blade, for example, using that same model and see what would happen to them if we took some CPU away. And if, based on the policy, that makes sense, we can project how much we'd hurt this virtual server by taking resources away. And if the policy defines it as less important than the one we're trying to help, that would make sense given the policy. On the other hand, if it's more important and we would hurt it, that doesn't make sense. So given that policy, we decide if it's a good trade-off. If it is, we can adjust the CPU allocations and move CPU from one virtual server to another. So as I said, this capability today exists for the Power Blades and ZVM, and this is areas where we'll be extending this management capability as we go forward. And then, as we just sort of alluded to, we're just introducing a set of APIs for, so all this management capability I talked about can connect into other management tools, and other management tools can interact with the Unified Resource Manager. And essentially what these APIs do is they allow programmatic access to everything I kind of just went through that you can do on the HMC in the original release. So you can understand the set of virtual servers that are defined in the environment. You can create them, you can change them, you can start them. All that monitoring data I talked about is available. And the goal here is really to enable the management of the environment from other tools, so it can be integrated with existing tools that people might be using. A little about these APIs. It's basically a new implementation, API implementation for Z. There was, on the HMC, there were existing APIs that were based on SNMP and SIM. We've integrated all those capabilities into these new set of APIs. The old APIs still exist, and will remain in place, but all the functions tied into this new zManager, zEnterprise capabilities are in the new APIs. They're based on a RESTful web services structure, which is a growing industry standard way of doing this sort of system management functions. Underneath it's a TCP/IP-based protocol. We use SSL for security. The approach used should be friendly for defining scripts for doing things. So modern scripting languages like Perl or Python can be used to automate managing the environment. And basically this is a fully documented, supported mechanism for managing the environment. And as we go forward, we'll be extending these APIs. Yes, Dave?
Now, the HMC has also been extended with roles and capabilities and granularity that wasn't there before. So security is still enforced at the HMC for these web services. So you'll have to think about, who do you want to give rights to, what passwords and usernames. But you've got much more granular control. It used to be you walk up to the HMC, you could do anything. Now it's much more specific and you can control. So if you give out an API, you're not going to give an API to students to let them spin up any guest they want, but you might be able to let them shut down their own machine. You have a lot of control.
Yeah, so
and that's still enforced at the HMC, regardless of how it's triggered.
Yeah, so part of these APIs, there's a log-on process to use these APIs, so you need a user ID and password, and that can authorize you to specific resources, like down to an individual virtual server. So,
yeah, that's really important because students will have access to this machine.
right.
Yeah.
And I think this might be these APIs may be valuable.
You want to be able to limit things.
Yeah, but I think the APIs may be an interesting thing to work with here, because it gives a lot of possibilities for managing the environment.
Those darn students, we know.
But
if
if you think about, from a research perspective, this could be very interesting, because if you've got a program that you've written that's doing research and you find out that you might need a virtual guest on a different platform, if you're a professor and you have the rights to do this, your application could actually automatically provision and deprovision capacity within your authorized limit. I mean, from a program, because it's just a web service. To initiate and start and stop and then pass work over, there's some really interesting possibilities.
Yeah, so I
here
think
for
this might be
research.
interesting as part of the overall work here to look at whether these APIs can be leveraged to do exactly that sort of thing.
Yeah.
And you remember that CSL Wave tool I mentioned to you before, they were one of the very first ones interfacing with this API.
Okay, so I guess that was essentially what I wanted to go over. This is just kind of the summary chart. So any other questions about the environment the structure, the Unified Resource Manager.
How long have you been working on this?
I was just trying to, it's been about 4 years that since Jeff started before, and I came on relatively early as the thing evolved. And it's been interesting to see it evolve from the initial ideas to what actually got delivered. So it's been a fun project.
Peter, do you estimate how many lines of code are in the Unified Resource Management? Just curious if you have to know.
I haven't seen an actual estimate, but it's millions of lines of code. So there's a lot of function there.
How many did you write?
I have to go back and count.
I thought he was an architect.
Any other questions?
Very nice.
Okay, thank you very much. and
Thank
thanks for
you.
the good discussion.